Every new generation of mobile networks brings more speed and new functionalities. With an increasing number of users demanding high-quality transmissions and more data, every mobile technology has reached the limit of what they were able to deliver. 5G has promised high performance and connectivity for millions of devices. 5G industry has made great economic efforts investing in the radio access network segment, providing support for massive MIMO, millimeter waves to deliver gigabit data rates, low power small cells, and beamforming for reducing interfaces. The other segments of a 5G network must allow different tenants to share the same physical infrastructure to save capital and operational costs. Legacy mobile networks are based on dedicated hardware resources. However, 5G networks are based on virtualization and softwareization using SDN and VNF technologies to allow the deployment of different logical networks on top of the same physical infrastructure. Network slicing has emerged as a key enabling technology in 5G networks, allowing system administrators to deliver services with guaranteed quality of service requirements. We have validated our solution with 5 IoT cases representing the categories defined by ITU: ambient monitoring in smart agriculture, demanding connectivity for a vast number of IoT devices, sound analysis in smart cities with a high number of IoT devices transmitting at a moderate bitrate, video surveillance in smart buildings where a moderate number of IoT video devices send real-time images demanding high bandwidth, augmented reality in industry, the most demanding scenario where ultra-low latency broadband traffic is processed, and finally, robot control in industrial automation, where ultra-low latency and high reliability are crucial for critical communications. The traditional data plane has to be enhanced to allow the tenants and system administrators of the 5G network offer IoT services with diverse QoS requirements. Without a fine-grained network slicing able to deal with 5G multi-tenant traffic, all the traffic is treated equally and the service level agreements cannot be guaranteed. How do we solve this? Our proposal is a novel 5G IoT framework with network slicing capabilities to provide multi-tenancy, user mobility across the antennas, and network slicing for different types of IoT traffic, scalable massive machine-type use cases, delay-sensitive critical communications, or enhanced mobile broadband services demanding high data rates. It supports heterogeneous IoT traffic and an adaptive management of the slices across the software data path. Now, network slicing allows to isolate and guarantee the network resources needed by every slice, delivering the QoS requirements requested by the users. Our framework has been validated in our 5G infrastructure at the University of the West of Scotland (UWS), gathering real 5G traffic from IoT devices used in our testbed to carry out the experiments. In a smart agriculture scenario, we are able to provide connectivity for up to 1,000 smart farms with up to 1,000 climate sensors, that is 1 million IoT devices connected to the 5G network. For delay-sensitive traffic in a robot control use case, ultra-low delay less than 200 microseconds is achieved with 0% packet loss. In smart cities, the network processes data from 24 cities with 3,000 sound sensors each. In smart buildings, the 5G network is receiving broadband traffic from 4,000 video cameras deployed in 40 buildings, reaching 15 gigabits per second in total. Finally, in manufacturing industry, traffic combining high reliability, low latency, and broadband requirements is successfully handled, reaching over 15 gigabits per second. To conclude, the proposed 5G IoT framework is able to support 5G features to ensure multi-tenancy and user mobility and to deal with diverse IoT use cases with different QoS requirements. It supports 1 million devices in massive type communications, reaches over 15 gigabits per second in eMBB, and ensures delays in the order of microseconds for ultra delay sensitive use cases with high reliability in all the scenarios tested.